We are going to look at two different numbers, 96.0 and 96.06, as a way to learn a little bit about significant figures. So let's take a look at 96.0. That number has 1 0 past the decimal point, which we can say is where all the error is. So that means that it is precise to 0.1 grams. Now let's look at 96.06. Here we have all of our error represented in that 6, and that is 2 places past the decimal in the hundredths place, which means that it is precise to 0.01 grams. Now, let's add them up. So 96.06 plus 96.0, you can do this in your head or you can take out a calculator. Either way, you're going to come to 192.06 grams. Now, I'm going to put a little dashed line in here, and that's going to show us where our precision ends. Everything to the right of that dashed line represents a pretty big level of precision. Everything to the left is a level of precision that is common amongst the numbers we're adding together. So 96.06 is a more precise measurement. 96.0 is a less precise measurement than the previous one. So that means that our result cannot be more precise than our least precise measurement. So that means I have to use that 6 to round that 0 up to the number 1, which means that my answer is 192.1 grams with the proper number of significant figures. Now let's take a look at multiplication and division with two new measurements. 15.0 milliliters and 0.9984 grams per milliliter. 15.0 milliliters, that number has 3 significant figures, and 0.9984 grams per milliliter, that has 4 significant figures. So let's multiply them together and we'll get a mass. Multiplying density by volume, that gives us mass. So when I do that, my calculator tells me that the result is 14.976 grams, and you can do that on your own and the math will check out. But 15.0, that has 3 significant figures, and 0.9984 grams per milliliter, that has 4 significant figures. So when I multiply those two together, I have to follow a new rule. Our result cannot have more significant figures than the figure with the fewest significant figures. That's a lot of use of the word figure in that bullet point. But here's the thing to keep in mind. I can only have 3 sig-figs in my result. So I'm going to draw a little line under that 9 right there to show you where my number is supposed to end. Now, I can't just get rid of that 7/6. That's useful. I'm going to use that to round that 9 one way or the other. Turns out that this number is much closer to 15.0 than it is to 14.8, so the answer I should have is 15.0 grams with the right number of significant figures. Now, there's a few things I'd like you to remember. One, significant figures apply to all measured numbers. If you're ever measuring something, there's a significant figure issue that you're going to have to deal with. Next, the rules for addition and subtraction will always go with the least precise number, and the rules for multiplication and division will always go with the fewest number of significant figures you have. Now, when you're doing these together, you're going to have to follow the orders of operations. That is, when you're doing math, if you have mixed operations like addition and multiplication, there's going to be an order that you do these things in. So I'm going to give you an example right here. Now, try and wrap your heads around that. If you put it into your calculator and you do it properly, and then you round at the right point to get the right number of significant figures, you should come up with a result of 320 J or 320 joules. Give this one a shot and see if that's what you come up with. I'll see you in class.